Okay, so in this second problem, a block is acted upon by the force P and 800 Newton. These are the two forces. So, this is 800 Newton and this horizontal force is P, and the coefficient of static friction is 0.35 and coefficient of kinetic friction is 0.25. So, we have to determine the force P required. First is to start the block moving up the plane, and in the second case to prevent the block from sliding down. Okay. So, consider the first condition. To start the block moving up the plane. So, what is the value of P? So, how much force P is required to start the block moving up the plane? Okay, so, for that we have to visualize the impending motion. Okay. So, we have to find out the force P when this block will have the tendency to slide up the plane. So, in that case the impending motion will be like this. So, this is your impending motion. So, you can see the complete motion in the animation. Okay, so, here block is sliding up the plane. So, now to find out the P value, we have to draw the free body diagram. Okay. So, this angle, that is angle of plane, this is given as a 25 degree. Then at this point we have one horizontal force which is the P, which is to be determined. Then there is a vertical force. So, this 800 Newton, it is the self weight of this block. So, this is 800 Newton. Okay. Then there will be normal reaction which is exactly perpendicular to the inclined plane. So, this is normal reaction. And as the impending motion is up the plane, the frictional force will be exactly opposite to the impending motion. So, this is the frictional force which is the F max. Okay. So, right now here we will consider the friction to be the limiting frictional force. Okay. So, for this value of P, block will be on the verge of motion. So, let us take the from the calculation we get the value of P as a 50 Newton, that is the required value to cause the motion. Okay. So, that means for 50 Newton block will be on the verge of motion. Okay. So, that is the equilibrium point. After this 50 Newton, even if I increase the force by 0.1 Newton, that means if I apply the force 50.1 Newton, then the motion will be like this. Block will enter into the dynamic state. Okay. So, up to 50 Newton block is still in static equilibrium and the friction is the limiting friction. And therefore, we consider the friction as a F max value. So, this is the frictional force which is a F max, which is along the plane. Okay. Now, here we will assume the reference axis like this. This x axis is parallel to this plane and y axis perpendicular to the plane. Now, observe the forces. This normal reaction is along the y axis or parallel to y axis. The F max is exactly parallel to x axis. So, no need to resolve F max and this normal reaction, but we have to resolve this 800 Newton. Okay. So, observe here 800 Newton is exactly vertical and it is inclined to y axis. So, we have to resolve that force. Force P is exactly horizontal, but it is inclined to this x axis. So, try to resolve these forces. So, for that you can resolve the force at this point or at any other point along this line of action. So, just I will consider the point here and then draw the vector parallel to y axis, draw the vector parallel to x axis. Now, observe the direction of this arrow. Okay. So, component must be in the same direction. So, this is the direction of x component and this is the direction of y component. Okay. Now, here if you observe the angle, so this is 25, that means this is the alternate angle, it is a 25. Okay. So, if this is 25, then this angle it will be same, it is a 25 degree. So, this is 25. So, x component is p cos 25 and the y component is p sin 25. So, in this way we can find out the x and y component for the force P. Similarly, you can resolve the 800 Newton. Okay. So, for the 800 Newton, you can resolve the force at this point only. So, draw one vector parallel to inclined plane or parallel to this x axis, draw second vector parallel to y axis or perpendicular to the inclined plane. Okay. Now, angle of this force with the y component, this angle it is equal to angle of plane. Okay. So, angle of plane is 25. So, this angle is same, this is 25. So, the x component it is the opposite component. So, this is equal to 800 sin 25 and here x component so this x component will be 800 cos 25 because this is adjacent component. Okay. So, in this way we can draw the free body diagram. So, here we are considering the case where the impending motion is in the upward direction. So, whenever you solve the problem on the friction, you must show the direction for the impending motion, because depending on the impending motion we will decide the direction of the frictional force, and after this you can write the condition for equilibrium. So, write summation f x 0. So, for the summation f x consider all x forces. So, first is 800 sin 25, it is positive. Then next x component p cos 25 and it is on negative x direction. So, minus p cos 25. Okay. Then we have the frictional force, which is the limiting frictional force F max. So, plus F max. Okay, no other force, so equal to 0. Now, here F max value, so we know the equation for F max, this is equal to coefficient of static friction into normal reaction, and mu s is given, this is 0.35. So, it is 0.35 into normal reaction n. Okay. So, put this value here. So, you will get the equation, this is 800 sin 25 minus p cos 25 plus 0.35 into normal reaction n equal to 0. Then write summation f y is equal to 0. So, for summation f y consider y component. So, first is normal reaction, then we have this 800 cos 35 in the negative y direction. So, minus 800 cos 25, then we have this p sin 25, it is also minus. So, p sin 25. Okay. So, only 3 forces in the y direction and this is equal to 0. So, from summation Fy you can find out the normal reaction. So, here the normal reaction, just solve this equation. Sorry, we can write the equation for normal reaction as this is 800 okay, n minus p sin 25 and this is equal to 800 cos 25. Okay. So, consider this equation, this is the equation 2. Now, from this equation we can write this is 0.35 n, then minus p cos 25 and this is equal to, take this term on the right hand side. So, it will become negative. So, minus 800 sin 25. So, this is equation 1. Okay. So, these two equations, these are simultaneous equation. So, I will write here the constant A1 into normal reaction, then we have the plus constant B1 into force P, this is equal to a constant C1. Second is A2 into normal reaction plus B2 into force P equal to constant C2. So, in your calci, in the equation mode, select the first equation which is having the format Ax plus By, this is equal to C. Okay. And then substitute these values. So, here the coefficients A1 is nothing but 1. So, you will get one matrix in your calci. So, here first value will be 1, after that put value minus sin 25 and here this constant which is the 800 cos 25. In the second column you can substitute second row 0.35 minus cos 25 and here this is minus 800 sin 25. Okay. Then press equal to, you will get two answers. Okay. So, your first answer is nothing but normal reaction and second answer will be force P. So, the normal reaction and force P, so I have only the force P which is 780.42. So, force P required which is 780.42 Newton. Okay, so, you can check this answer. Okay, so now refer the second case. Second is to prevent the block from sliding down. So, to prevent the block from sliding down, What is the direction of frictional force? So, direction of the frictional force will be impending motion of this block, it will be in the downward direction. Okay. So, to prevent this downward motion, we have to apply the minimum force. Okay. So, this force will just keep the block in the given equilibrium. Okay. So, because of this force, block will not move in the upward direction, but if you remove this minimum force, then block will have the tendency to slide down the plane. Okay. So, we have to find out the minimum force to keep the block or to prevent the block from sliding down. So, now here you can observe the impending motion. For the minimum condition, impending motion will be down the plane, and therefore, friction at this contact surface will be like this. So, this is your maximum frictional force when the impending motion is downward direction. So, now you can draw the free body diagram. So, this is the force P. So, I will consider this is a minimum force, then this is the 800, this is normal reaction, and this is the frictional force. So, this is F max. Now, we have to resolve the forces similar to the last problem. So, this is 25. So, you can resolve the force P. This is y component, and component parallel to plane, this is x component. Similarly, resolve the 800 Newton. So, this is the x component, this is y component for 800 Newton. This angle is 25. Okay. So, this is equal to, so here this angle is 25. So, this is P cos 25, this is P sin 25. So, only difference in the last free body diagram and this free body diagram is direction of the F max. Okay. So, right now this F max, it will prevent the downward motion. Okay. So, now use the condition of equilibrium. So, summation f x 0. So, for summation f x 0, this force is 800, this is sin 25. So, 800 sin 25, then minus P cos 25, sorry, plus minus P cos 25 and minus this F max, and this is equal to 0. So, F max is nothing but mu s into n. So, this is mu s normal reaction, mu s value is 0.35 into normal reaction. So, this is equal to, just I will write this in this format, minus P cos 25 minus 0.35 n, and this is equal to minus, sorry, yes, minus 800 sin 25. Okay. So, you can cancel out the minus sign. So, you will get P cos 25 plus 0.35 n, and this is equal to 800 sin 25. Consider this is equation 1. Now, write this summation f y. Okay. So, for summation f y, normal reaction in the positive y direction, this y component, so it is 800 cos 25, so minus 800 cos 25, this y component minus P sin 25. Okay. So, this is equal to 0. So, you will get the equation minus P sin 25 plus n, and this is equal to 800 cos 25. So, to solve the equation directly in your calculator, we must shift the constant value on the right hand side. So, this is your equation 2. So, solve these two equations simultaneously and get the value of force P, which is the minimum force. So, from your calculation you will get the answer. So, this is equal to 80 Newton. Okay. That means, if you just apply 80 Newton at this point, then it will prevent the block sliding down. So, it will maintain the equilibrium, but because of this force, block will not move in the upward direction. Okay. For the upward direction, we have to increase this value, okay, and increase this value up to the force 780 Newton we have calculated in the first condition. So, if the force is equal to 780 or greater than 780, then block will be in the complete motion of the plane. Okay. So, this force, it will just prevent the block sliding down. So, what will happen if you remove this force? So, if you just reduce the force, if you apply 79 Newton, then because of 79 Newton, block will slide down. So, this is the condition. So, to prevent this from sliding down, we have to apply at least 80 Newton force. And in the same, the third condition is, what is the value of force P to keep the block moving up. That means, for complete dynamic condition, what is the value of P required? Okay. So, for this we have to use the coefficient of kinetic friction. Okay. So, try to solve this condition as a homework, okay, and then find out the P value, so that block will be in in complete motion in the upward direction. So, this is the dynamic condition. So, for the dynamic condition, the F value is equal to mu k into normal reaction, and then find out the P value. Okay, so, we will stop here.